What if I told you that our galaxy, the Milky Way, lives inside a giant empty bubble in space? A place where there are far fewer galaxies than usual. A region so vast that light would take billions of years to cross it. Scientists call it the KBC Void, and it might be one of the largest empty regions in the entire universe. If this is true, it could completely change how we understand the universe's shape, its speed of expansion, and even our place in the cosmos. The story starts in 2013. Three astronomers, Ryan Keenan, Amy Barker, and Lennox Cowie, were studying how galaxies are spread out in our part of the universe. They looked at over 35,000 galaxies and found something strange. Around our Milky Way, there were about 20% fewer galaxies than expected. It wasn't just a small empty spot. It was a huge region stretching billions of light years across. They realized our galaxy might sit inside a massive underdense bubble, a kind of cosmic valley surrounded by distant mountains of galaxies. At first, many scientists were doubtful, but over time, other surveys like 2MASS, WISE, and Cosmic Flows found signs of the same thing. It began to look like the KBC Void might actually be real. To understand this, imagine the universe as a giant cosmic web. All galaxies, stars, and dark matter form a massive 3D network, a bit like soap bubbles or spider webs in space. The bright, glowing filaments are where galaxies are packed close together. Those are the clusters and walls. But most of the universe isn't filled with galaxies at all. In fact, about 90% of space is made of empty regions called voids. The KBC Void, however, stands out. It's so large and so deep that if confirmed, it could be one of the biggest cosmic voids ever found, maybe up to 3 billion light-years wide. So what does it mean for us to live inside this huge empty region? It affects how we measure the expansion of the universe, something scientists track using the Hubble constant. When we measure nearby galaxies, the universe seems to be expanding faster than when we measure it using light from the early universe. This difference, about 9% faster, is known as the Hubble tension. If we live in a large underdense region like the KBC Void, that might help explain why. Inside a void, there's less matter and less gravity pulling things together, so galaxies drift apart faster. It makes it look like the universe is expanding more quickly from our point of view. It's like standing in the middle of an empty balloon, while the edges stretch out faster than you expect. Your local view feels different from the big picture. Here's another interesting thing. Inside voids, gravity is weaker, so dark energy, the mysterious force pushing the universe apart, becomes more powerful. This imbalance causes galaxies, including ours, to slowly drift toward denser regions nearby. Our Milky Way is actually moving at around 600,000 miles per hour, pulled by stronger gravity outside the void. And scientists have even found faint clues of this in the universe's oldest light, the cosmic microwave background. When light passes through a giant void, it loses a bit of energy, leaving tiny cool spots. Some of these cool spots could be evidence of the KBC Void's influence. For a long time, astronomers have believed something called the cosmological principle, the idea that the universe looks roughly the same everywhere, no matter where you are. But the KBC Void challenges that idea. If our galaxy really does sit in such a massive underdense region, it means our location isn't completely ordinary. It's not that Earth or the Milky Way is at the center of the universe, but it might mean we're in a less typical part of it. Simulations of the universe rarely produce a void this large, so either we found something truly rare, or there's something missing in our understanding of how cosmic structures form. It's a humbling thought that even after centuries of exploration, we might still be discovering how special or how unusual our cosmic neighborhood really is. To find the answer, we have to go back, all the way to the beginning of the universe. Right after the Big Bang, the universe wasn't perfectly smooth. Tiny fluctuations in density, caused by random quantum effects, made some areas slightly denser than others. Over billions of years, gravity pulled the denser regions together into galaxies and clusters, while the emptier regions became even emptier. That's how cosmic voids formed, expanding regions where matter is scarce. But computer models rarely produce voids as big as the KBC one. That's why many scientists think there could be more going on, maybe involving dark energy, dark matter, or even new physics we haven't discovered yet. Galaxies that live inside voids are quite different from those in crowded parts of the universe. They're often smaller, dimmer, and isolated. They form stars slowly because they rarely collide or interact with other galaxies. Interestingly, many of these galaxies still have large amounts of hydrogen gas, the raw fuel for making new stars. They just don't use it as quickly. Scientists study these lonely galaxies to understand how isolation affects cosmic evolution. And since our Milky Way lies near the edge of the KBC Void, some believe this calm, low-density environment may have been perfect for life to develop. Fewer galactic collisions, less radiation, and more stability over time. It's fascinating to think that our peaceful corner of the cosmos might owe its serenity to the emptiness that surrounds it. The mystery of the KBC Void is far from solved. New telescopes and space missions, like Euclid, the Vera Rubin Observatory, and the Roman Space Telescope, are designed to map the universe in incredible detail. They'll show us how galaxies are arranged across billions of light years and help confirm whether the KBC Void is real or if something else explains what we see. If it's real, it could finally help solve the Hubble tension and teach us more about how dark energy works. If not, we may uncover something even more mysterious, a completely new layer of cosmic physics waiting to be understood. So here we are, floating in one of the emptiest places in the universe. It might sound lonely, but this emptiness could be the reason we exist at all. The KBC Void challenges our models, bends our measurements, and reminds us that even the empty parts of space can reshape our understanding of everything. Maybe the biggest mysteries of the universe aren't hidden in distant galaxies or black holes. Maybe they're right here, in the vast, quiet space we call home. This is Eternal Skies, where we explore the cosmic stories that make you look up and wonder. If you enjoyed this journey through the void, hit like, share, and subscribe, because the more we learn about space, the more mysterious it becomes.